Good day everyone. We continue with chapter 8 and we are still under the subtopic 8.4 ellipse. Today we'll be looking at example 21, 23 and 24. Let us look at example 21 first. Show that the equation 25x squared plus 150x plus 4y squared plus 125 equals to 0 represents an ellipse. Hence, sketch the graph. So we have to rewrite this equation into a standard equation of an ellipse by using the completing the square method. So we have to group all the x together, but since we don't have any y term, so we just leave 4y squared alone. And the constant, we bring it to the other side. And to make completing the square easier, we have to make sure that the coefficient of x squared is 1. So therefore we factor out 25 and now the coefficient of x is 6. To have a perfect square, we need to find a value here. And to find that value, what we do, we just take half of this value, which is half of 6, which is equals to 3, and square of 3 is 9. So therefore that's the value. And this value is to balance up the value that we have just added to this side, which is 9 times 25. So now we can factorize this and we get a perfect square, x plus 3 squared. The standard equation of an ellipse, this side must always be equals to 1. Therefore, what we do, we have to divide everything by 100. Simplify, we get this. And rewrite this, the denominator into squared form so that we can identify the value of a and b easily. So as you can see, center HK is -3, 0. And a is always the greater denominator. So a is 5, b is 2. And by looking at this equation, we know that the major axis is parallel with y-axis. So these are the information we have gotten so far. Now we can find c using the formula of square root of a squared minus b squared. Substitute the values of a and b. So therefore c is equals to square root of 21. Vertices, since we know that the major axis is parallel to y-axis, so therefore to get vertices, we just plus minus a to the coordinate y of the center. So our vertices is -3, 0, plus minus 5. Therefore, the coordinates are -3, 5, -3, -5. Similarly to foci, since foci are also along the major axis, to find foci, we just plus minus c to the y coordinate of the center. So therefore, foci are -3, 4.6 and -3, -4.6. So length of major axis, formula is 2a, therefore it is equals to 10. And length of minor axis is 2b, therefore it is equals to 4. So now we can sketch our graph. We can start by marking our center, which is at -3, 0, and followed by our vertices. And even though we didn't find the coordinates at the end of our minor axis, but we can just mark that because we know that B is 2. So from here to the coordinate of at the end of the minor axis is 2, and from here 2 units. So therefore it is -5, 0 and -1, 0. We can now draw a rectangle to make it easier for us to draw the ellipse. But if you want, you can just draw the ellipse right away. Foci, don't forget to mark it on your graph. So this is the graph of our ellipse. Example 23. Mr. Gauss, a retired mathematician, has a garden in the shape of an ellipse in his backyard. He placed a water sprinkler at each focus. If the major axis is of length 8 meters and the minor axis is 6 meters, estimate the distance between the two water sprinklers. So we are given length of major axis 8 meters, and we know that the formula of length of major axis is 2a. Therefore, value of a is equals to 4. Minor axis is 6. Therefore, b is equals to 3. So now we can find value of c. Remember that c is the distance from the center to the foci. And the distance between the two water sprinklers which place at both foci is 2c. So therefore c is equal to square root of a squared minus b squared. Substitute the values and c is equal to 2.646. Therefore, the distance between the two water sprinklers is 2c, which is 5.292 meters. The last example, example 24. The arch of a bridge forms the top half of an ellipse. The arch is 6 meters high above the 20 meters wide river. Question A. Write the equation for the ellipse in which the water level coincides with the major axis. And question B. A flagpole is placed at the focus of the ellipse. Find the distance of the flagpole from the center. So this is the illustration of the arch and the river. It is 20 meters wide and 6 meters high. So since for question A, we take the major axis as coincide with the water level like this, then we position our x-axis and y-axis so that the center is at 0, 0 here. So we can now write the value of A. A is equals to 10 because from here to there, that is A. And B is 6 since this is half ellipse. And we take this as center of the ellipse, which is 0, 0. Therefore, the standard equation, observe that our major axis is along the x-axis. Therefore, a squared must be the denominator for x squared. So substitute all the values. Therefore, this is the equation of this ellipse. Okay, question B, asking for the distance of the flagpole which is placed at the focus. Remember that the distance from the center to the focus is given by c. And the formula to find c is the square root of a squared minus b squared. Substitute the values of a and b. Therefore, c is equals to 8. Therefore, the distance of the flagpole from the center is 8 meters. So that's it for today. Thank you. Stay safe and have a nice day, everyone. Bye.